Hi guys, today's video is going to be covering what we call an ellipse. An ellipse you can think of like an oval, and when we are looking at a cone, we get the ellipse from slicing the cone from one side to the other at a slant. So if you look at the picture over on the side, which you guys have seen before, the ellipse is that green color that we're working with today. So we've already done the circle, we've done the parabola. Today we're going to talk about the ellipse, and then next class we're going to be talking about the hyperbola. Now, remember we just said an ellipse looks like an oval, and there are two different kinds of ovals we can have. We can have an oval or an ellipse that goes side to side, like this one I have on the screen. We can also have an ellipse that goes up and down. So because we have two different directions an oval can go, we're going to have similar but slightly different equations. So I've gone ahead here and written the standard form for a horizontal ellipse. Notice that the equation looks similar to a circle. The major difference is that we're going to have denominators most times in our equation, as well as instead of equaling r squared, we're going to always have the equation equal to 1. And that's something we'll talk about a little bit later. If the equation's not equal to 1, you're always going to need to make sure that you change it so that it equals 1. All right? Now, when we are looking at this equation, the center is still going to be at HK, so that's no different from the circles that we dealt with in the first section. The big difference here is the a squared and b squared. So what I put in this little box off to the side here is that a is going to represent the distance from the center of the graph to what we call the vertices. And the vertices are 2 points that are in line with the center but go from one side to the other along the longest edge. Okay, so because this goes side to side, my vertices or my vertex is going to be on the left side and the right side. Okay, so those are 2 points, one side and the other. The B value is going to be from the center to what we call our co-vertices, and these are the points that are on the other sides of the ellipse. So they're going to go, in this case, up and down, and I abbreviate these with CV for co-vertex. Okay, so we have 4 points that we have to create the oval shape, our 2 vertices and our 2 co-vertices. So A and B are just numbers. That's the distances between them. So if you want to label this in your picture, that distance is A and this distance is B. And then the last one is C, which is our distance from the center to our foci or focus. So we had a focus in a parabola. It's going to be very similar. The focus is going to be 2 different points that are inside your ellipse, and they go in line with the vertices. Okay, so if our vertices go left to right, the focus on each graph goes left to right. Okay, so that distance from the center to the focus is distance C. Now, obviously you look at the equation, you see there is no C value in the standard form. So that's where this formula here that I've kind of boxed in comes in handy. It looks like Pythagorean theorem, but it's got a minus sign instead, and that's going to help us find that C value so that we can plot the focus in our graph. And we'll get into how we do that here in a second. The second formula looks just like the first, but notice now my ellipse goes up and down. So here I've got my center right in the middle. My vertices are going to be top to bottom this time, and then my co-vertices are going to go left to right. So what changes about the formula is that my y value comes first and my x value comes second. So they look almost identical in formula, except this time my y's and x's get flip-flopped. Nothing else changes in the equation. The a squared value is always first. The b squared value is always second, and a will always be bigger than b, so that's very important, okay? The c squared formula is still the same, so if I'm looking for my focus, I could still use that formula, but this time my focus points are going to go up and down because my vertices went up and down, okay? So 2 formulas, make sure you have both written down. Make sure you also add that A is always going to be bigger than B. That's very important. Okay, and now we're just going to go into 2 examples of graphing. So in this first example, it says to graph the ellipse. So if I give you the equation x plus 2 squared over 16 plus y minus 3 squared over 4 equals 1. We're going to go ahead and figure out how to find the center, the co-vertices, vertices, and foci. So to do that, first you always want to figure out the direction. that is purely going to be based on which variable comes first. So if you look at the equation, the x squared and the 16 are bigger and they come first. So that means that our graph is going to be going left to right. Now, if your equation was flip-flopped, then you want to be careful because remember, A always has to be bigger than B. So this is the A squared value, this is the B squared value. So even if they wrote the equation backwards, you always want to look for the bigger number in the denominator. That's going to tell you which letter should come first. Okay, so our graph is going to go left to right. Then what we need to find is our center, our A value, our B value, and our C value. If you can get those four things, you'll be able to graph everything very quickly. So the center always comes from the x and the y, so the x value is going to be -2, the y value will be +3. So we'll go ahead and get our graph set up. So we'll have the point -2, +3. And then we can find A squared by setting A squared equal to 16. So if A squared is equal to 16, that means A is 4. And because we said the graph goes left to right, that means our vertices will go left to right. So from the center, we're going to count over 4 to the right, 1, 2, 3, 4, and plot a point. And then from the left, or from the center, we'll go left, go over 4, plot a point. So there's our 2 vertex points. Then we can find the co-vertices by finding B. So B squared has to equal 4 because that's this value. So we get B is 2. So that means from my center, I'm going to go up 2 because my co-vertices go the opposite direction. And then I'm going to go down 2. So there's my co-vertices. And once you have that, you can connect those 4 points to make your oval. Do the best you can to make it look like an oval. Okay. And then lastly, we need to find our C value. That's for the foci. So remember the equation is C squared equals A squared minus B squared. So we could plug in what we know. We know A squared is 16, B squared is 4. So we get C squared equals 12. And when you take the square root of 12, you get 3.5. So now, because our vertices go left to right, our foci have to go left to right. So I'm going to count over 3.5. 1, 2, 3.5. So there's our focus, and then we'll go over 1, 2, 3.5. Whoops. There is our other focus. And your graph is done. Okay, so find the direction, find your center, and then you just need to find A, B, and C and plot your points. But knowing the direction is going to be very important. I want you guys to go ahead and try this example on your own. We got y plus 1 squared over 25 plus x minus 5 squared over 9 equals 1. So figure out the direction, figure out the center, and then find A, B, and C, and see if you can graph it. And if you'd like me to check that in class, by all means, go ahead and ask. And then in the next video, we're going to talk about writing the equations.